Okay, we're back. We've got our error metrics for our index forecast, and now let's make another one, or I'm sorry, not make another one, but create a calculation of all those error metrics for our linear regression forecast. So I'll go back to my linear regression forecast, move or copy, make a copy of this thing, create a copy, we're going to move it to the end. We are really so close to done. And this is going to be LR errors. So like we did when we were setting up our index, I wanted to get rid of everything superfluous. So where I just had my date, my deliveries, whatever pieces I need, like I needed my trend here to retrend my index, but we're going to do that for my linear regression. I am not going to need this chart, excuse me. I'm not going to need anything happening in the future. I've got a historical forecast. This historical forecast relies on me having already made that Saturday adjustment of 1.2. If we could do this twice to see whether our error was better with the Saturday adjustment or not, I did, and it's better without it. And so for that reason, I'm going to just return my Saturday adjustment to 1. I've got my historical forecast here now. I'm going to copy it. I'm going to paste it special. And the reason for that is that I want to just delete all the rest of this. Didn't I just copy and paste special? Command C. Paste special, values and number formatting. Are they? That's not values and number formatting. Copy. Can you guys are probably know exactly what I'm doing wrong. Oh, because I said formulas and number formatting. There we go. Nothing. Okay, got it. Clear, delete, whatever we want to do. But like I have in the index where I want to have deliveries next to historical forecast index, I want to end up with deliveries next to historical forecast regression. I'm losing my T, but it doesn't matter now. Great. All right. So I've got my deliveries, I've got my historical forecast, and now check me out because I've got error, absolute deviation, absolute percentage error, squared error, root mean squared error, and all of my descriptors that I can copy, bring over, and paste. Let's adjust these and make them wider. And let me just double check that what I have is what I want. And I'm going to remove those extra lines. Here, I am going to add a little line just to remind ourselves that each of these is our error metric, our average of the error metric. But let's make sure that this all looks right. So my error is equal to actual minus expected. Great. That is the absolute deviation of that. My percentage error is calculated as a percentage of actual deliveries. And my squared error squares the error. I'm going to try it one more time somewhere down below just to make sure there's not some sort of mistake. Actual minus expected, those two match as a percentage were correct, and that's the square. Here's one that has a negative error. This is a case in where our historical forecast overestimated, and I'm just looking to make sure that the absolute deviation of that is as it should be. So this looks good. That was easy. And so now we've got our forecast errors for our linear regression forecast. Let's redo this plot so we can see how well we can eyeball how close the linear regression forecast is to the actual data. remember if I used lowercase or uppercase. That's not the name. Okay, so I'm going to go back to my last one. What did I call this? Total deliveries and historical forecast index method. I'm just going to copy this. I'm checking my legend. I used all lowercase, so I'm going to stick with that here, and then I'm going to confirm that that's what I did. Consistency is everything. Well, it's not everything, but it's important. There we go. So now I can see, right, we didn't capture these tall Saturdays, that gap, we knew that. And that's fine, which is funny because here on the Saturday when we did a particularly poor job, it's because we forecasted a standard Saturday and it was a bad Saturday. Same thing happened on the other graph. I'm sorry, on the other forecasting method. So the last piece that we need to do is we need to make a comparison table. And in this comparison table, what I want is a collection of all of the average errors, all the mean errors. The mean error, the mean absolute deviation, the mean absolute percentage error, right? All the ways that we were wrong on average. I'm going to take them into the comparison tab. I'm going to paste them. I'm going to undo that. I'm going to try again. I'm going to paste special, taking just the values and the number formatting. I'm going to go up to view and zoom in a little bit so that you can see what I'm doing. So these can be my table headers. And what I have here are the errors from the index method. So I'm going to say index forecast, except it's getting late. I have to put it in the right box. And then down here is going to be my linear regression forecast. Let these be the same width. And I can make all these tables the same width, or all these columns the same width, and I can wrap the text. Great. Now let's go back in and just copy the average error terms from my linear regression forecast. This time we remember to paste special, taking just the values and the number formatting. And that looks good. This one is in parentheses because it's very, very slow, slightly negative, and that one's not in parentheses because it's very, very slow, slightly positive. But looking at this, we just did two pretty ambitious forecasts, calculated all of the errors. And what did we find out? You know, what I see here is that these guys are really comparable. You know, it's the difference between being off on average by 78,000 deliveries or 87,000 deliveries. Not a big win one way or the other. But the linear regression forecast did do a better job. It has a lower mean absolute percentage error, meaning that it's off by about 17% on average. And so we can see that the linear regression forecast performed better, both in the absolute deviation and the percentage error. It has a lower mean squared error, and it did slightly better with regard to root mean squared error. So I think overall this would be the forecast that has done better, at least performed better on the historical data, right? So what does that mean for the forecast that we've made with this? 17.21% off. Let's go back to our linear regression forecast. And I would just modify one thing. I'm going to go back to remove my adjustment, go back down to my adjustment of 1, because that's how I calculated my errors. And I'll come down to the date that I'm interested in. I'm interested here in November 16th. We've already sort of decided that if we're really committed to hitting that number, the million number, we should remove the friction. If I think that my forecast can be plus or minus, right, because we're off by 17.21% on average, I would maybe give myself a minimum and a maximum range for the forecast on the 16th. So November 16th forecast, we have an expected value is equal to here 953,000. But because our mean absolute percentage error is 17.21%, if we were off, I'm going to call it a lower bound, which has a technical meaning, so I probably shouldn't use it. But if I'm using my MAPE as to give me a range, it could be equal to our expected value multiplied by 1 minus the average percentage error. But as an upper bound, it could be equal to our expected value multiplied by 1 plus our percentage error, in which case we would, definitely hit a million. Well, not definitely, right? Because it's probable. So it would be if it was a good Saturday. I guess that's what I'm trying to say. Definitely hit a million. I should never say that, because definitely that is not true. What we have is that if it's a cracker of a Saturday, sure, we'll hit it, which is about sort of what we've been thinking before. All right, I don't know. Okay, all that for an I don't know, but thank you for sticking with me, and thanks for being willing to do today's lecture online to let a lot of our colleagues go to a networking event, and I think everyone appreciates it, and I hope you've enjoyed having the evening off and working at your own pace. Okay, I'll see you next week, and stay tuned because there will be some prep work posted in the next couple of days. All right, thanks a lot.